In this section, we're going to talk about implicit differentiation, which is kind of a new process, a new way for us to take derivatives. But it's helpful, I think, to compare it and contrast it with the way that we've been taking derivatives up until this point, which has been using explicit differentiation. So if I wanted to use explicit differentiation, there's really two steps to it here. We would solve for y, or f of x or g of x or whatever your function is called. And then two, we would take the derivative. Now, normally we haven't had to do that first step because we've always had something that looks like y equals or f of x equals. So we really haven't had to do that first step ever, but here's an example where I might have to. If I have 3x squared plus y minus 2 is equal to 0. So I'm just going to copy that problem down here. I've got 3x squared plus y minus 2 equals 0. So my first step here says I'm going to solve for y. So this would mean add 2, subtract 3x squared from each side. So y equals 2 minus 3x squared. There, now I have y by itself. My next step, I can take the derivative, so I can say y prime, or you could say dy over dx, whatever your preferred derivative notation is. Derivative of 2 is 0. Derivative of negative 3x squared is negative 6x using our power rule. So there we go. This one's not too bad to do using explicit differentiation, but as we'll see in the coming videos and in the coming examples, explicit differentiation is not always going to be easy for us to use. It's going to be to our benefit to use this new process of implicit differentiation that we'll talk about in the next video.